Good morning to all of you.
Good morning, sir.
To all of you.
Good
So by
morning,
this
sir.
time, probably you had attended one class by this time. Okay. So we had discussed many things. I hope you had understood at least something. In the last class, when it was, we had discussed double reinforced design section, and we tried to find out, we tried to see the solve problem for that, right? So in there we had tried to find out, we are given the cross section of the member, the amount of tensile steel as well as amount of compression steel, the grade of concrete, grade of steel, all things, those things were given. We were asked to find out what will be the moment of resistance of the section. But when we, as a student of design of structure, we will be given the bending moment, external bending moment. We will be asked to design. We will be asked to design the section. So design the section means we have to find out the breadth and depth of the member, as well as amount of steel required, both tension and compression. Only thing that we have to assume the grade of concrete and grade of steel. That is the freedom in our hand. Only freedom is in our hand is assumption of grade of concrete and steel. So as per IS 456 as well as 1893, that we will learn later. For structural concrete, minimum grade of concrete is M20, and steel normally it is Fe415. Even we can go Fe500. Now even we can go to Fe550, right? In normal, M20 and Fe415 steel is utilized. So now let us see, we are given a problem, the factored bending moment of 280 kilonewton meter. Bending moment and factored bending moment. You always try to remember, because in theory of structure, you will learn what is factored moment. In theory of structure, it will not be called factored moment, it will be called plastic moment. So that you will learn in theory of structure. That plastic moment in design of structure, it is called factored moment, right? Why it is factored moment? The moment with respect to elastic condition will be multiplied by a partial safety factor, and that's why it is factored. Sometimes you will be given the bending moment. If the word factor is not given, only bending moment is given, then you will be required to multiply that value by partial safety factor as per given in IS 456. IS 456 will be permitted to you in your examination, and in your day-to-day life. You will be required to utilize IS 456. Okay, now here we will be required to find out what is it. We are given the factored moment 280 kilonewton per meter. We can assume the grade of concrete and grade of steel. Now, what we have to find out? So first we have to find out the cross section required. Then we have to find out the amount of steel. When we are talking about the cross section required, width of the member and depth of the member. Now depth of the member is related with effective depth and effective cover in tension zone, because overall depth is equal to effective depth plus effective cover in tension zone. Okay, so our unknown is overall depth, effective cover, and B. Okay, so overall depth, effective puffer, and width. Up till now, we got 4 unknowns. Then we have to find out the area of steel required in tension zone, area of steel required in compression zone. See, there are 6 unknowns. So if we want to solve this in mathematics, applied mathematics, then we will be required 6 simultaneous equations. So if 6 simultaneous equation by manual calculation, it will not at all be easier, because it will be 6 by 6. Ultimately, if it will be a 6 by 6 unknown solution of 6 unknown is very tedious thing. Okay, so ultimately, if you go by matrix, it will be 6 by 6 matrix. So again, here you will be required to find out some programming. So in software, there are some software. In software, you just put the some values and you will get other values. So under these circumstances, we are having one way that out of these 6 unknowns, we will assume some values from our past experience, and we will establish that our assumptions are correct, and other values we will try to find out. Right? Now see here, I had what I had done here. So factored moment. Then let us assume, let us use M20 concrete and Fe415. Okay. Now here in problem, it is not said design a rectangular beam and find the amount of steel required. It is a open-ended problem. This problem you can solve a single reinforced section also, whatever we had solved previously. Okay, but since we are dealing with double reinforced, so we try to find out double reinforced. And from the experience of the last few classes, if factored moment increases, then cross section of the member also increases. Then depth increases. A situation may arise that it is not practically possible to use the whatever depth required. So under that circumstances that we have discussed, we are to go for double reinforced section. So here I am giving a statement. Let us design as a double reinforced. So when double reinforced, so in previous problems, whatever we had solved, we had obtained. We have tried to find out the moment of resistance of the section. So when we have tried to find out the moment of resistance, we have find out the moment of resistance with respect to compression zone and with respect to tension zone. And when we try to find out the moment of resistance with respect to compression zone, we have considered the compression concrete area and compression steel area. Okay, compression steel area. Now this compression complete area now these two. If I talk MUR is equal to M1 plus M2. This M1 is the moment of resistance as single reinforced, and M2 is the moment of resistance with respect to compression steel. So these two. Out of this, one we can achieve. So from our normal practice, since there is a cross section, the larger part of the external moment, vector moment, will be resisted as balanced section. Okay, and other part will be resisted by the compression steel. So that's why major part. So that's why I had assumed 60% of the factor moment is resisted as singly reinforced section. Now this 60% is not always constant. Only thing that we try to find out major part, that means more than 50%. So you can consider 55%, you can consider 60%, you can consider 62%, you can consider 63%, and so on. Okay, but it cannot be 100%. If it is 100%, it becomes a single reinforced section. So now see here. So we have, so mu limit is equal to 0.6 MUR. MUR. MUR is equal to mu. This we have at the very beginning. MUR is moment of resistance, factored moment of resistance, and mu is the factored moment. So moment of limiting moment of resistance, MUR. Okay, so ultimately 168 kilonewton meter will be resisted by the section as singly reinforced section. Okay, so if singly reinforced section, now come here, critical neutral axis depth with respect to M20 and Fe415, it's 0.48 D, where D is the effective depth of the section. Remember, D is not yet known. D is not yet known. That means our XU maximum we got in terms of unknown D. And for this, we had got one expression, mu limit is equal to 0.138 FCK BD square. This expression we have. Out of this, mu limit is known to us, FCK is known to us, but B and D are unknown. B and D are unknown, and how to find out this? Okay, so we got say 168 into 10 to the power 6 is equal to 0.138 into FCK 20 BD square. So BD square is equal to this. Okay, now here we want to relate rate V and effective depth.